equations, obtain the Z transform and ROC. ठीक है, इसका ROC भी निकालना है आपको. As we know, if we have to just obtain the Z transform, definitely we'll have to find the ROC as well. ROC of x of n given is 7 into 1 by 3 to the power n un minus 6 into 1 by 2 to the power n now un. Now this particular sequence is having two parts. This is the first part and this one is the second part. So we have to see how we can obtain its Z transform and accordingly how the ROC would be. Okay? Now to solve this question, we will directly write the x of z of it. It is going to be summation, nothing similar attached to it, 0 to infinity 7 1 by 3n z to the power minus n minus summation n 0 to infinity 6 1 by 2n z to the power minus n. Both the limits will be 0 to infinity because it has un attached to it. Okay? Now x of z can be written as, here 7 will be taken out of the summation n 0 to infinity, this is 1 by 3 to the power n z to the power minus n, hence we can write to the power n. 1 by 3 into z to the power minus 1 to the whole power n minus 6 is taken out of the summation n 0 to infinity, this becomes 1 by 2 z to the power minus 1 n. Clear? Now further if we solve this one, this x of z becomes 7 by 1 minus 1 by 3 z to the power minus 1. As we all know, the answer of this summation, if it is n 0 to infinity something to the power n, becomes 1 by 1 minus that particular term. ठीक है? Minus 6 by 1 minus 1 by 2 z to the power minus 1. Now this is going to be my x of z. Clear? The z transform. Now in this one, when this is the x of z, for the x of z to converge, what should be the answer? That is, अगर ये converge होना चाहिए, then in that case, for x of z to converge, it should be 1 by 3 z to the power minus 1 mod should be less than 1. This is our first condition from the first term, that is this particular thing. This one 1 by 3 z to the power minus 1 का mod should be less than 1 and अभी and मतलब ये भी होना चाहिए, mod of 1 by 2 z to the power minus 1 should also be less than 1. That means both the things should be followed. This should be less than 1 and even this should be less than 1. Now from this one we can have that mod of z should be greater than 1 by 3. ठीक है? Mod of z should be greater than 1 by 3 from this, and mod of z should be greater than 1 by 2. From this we have got that mod of z should be greater than 1 by 3, and from this we are getting that mod of z should be greater than 1 by 2. Now if you plot the ROC, now this is going to be our ROC. ये हमारा ROC हो जाएगा, and if you plot it, this is real z, this one is imaginary z. Now we know that 1 by 3 will, let us take somewhere come here. This value is 1 by 3. Now somewhere here we get the value 1 by 2. Okay? So if we take the first value, that is the first condition, mod of z should be greater than 1 by 3. Now if you plot a circle with the radius of 1 by 3, it will be like this. And if you plot a circle with the radius of 1 by 2, it will be like this. Okay? So the first ROC says that the outer of the exterior of the circle of radius 1 by 3. And the second ROC says that the exterior of the circle of radius 1 by 2. Now we have to take both. That is, it is and हो रहा है मतलब we have to take both the conditions together. That means the ROC will be the exterior of the circle of radius 1 by 2, which is common in both. जो दोनों में common है. ठीक है? So we have to take the exterior of the circle. ROC will be what? ROC will be mod of z greater than 1 by 2. ठीक है? Because that particular region is common in both. So that is what is going to be our ROC. 1 by 3 से भी greater होगा और 1 by 2 से भी greater होगा. ठीक है? So that is what is the ROC. The mod of z will be greater than 1 by 2. Clear? So this is going to be our ROC. And since we have, if we calculate our x of z further, अगर हम इस x of z को further solve करते हैं, it will be of the form z into z minus 3 by 2 by z minus 1 by 3 into z minus 1 by 2. Now from this, let me just explain you one important point. If we solve our x of z further, it will be of this form. हमें ये form मिलेगा z into z minus 3 by 2 by z minus 1 by 3 into z minus 1 by 2. Now from here, we can find the poles and zeros. Now what are poles and zeros? Poles and zeros are the location. Basically poles वो value होते हैं z की जो denominator satisfy करता है. Now the values of denominator will be z equals to 1 by 3 and z equals to 1 by 2. So these are the values of poles. ठीक है? तो यहाँ पर values of poles are z equals to 1 by 3. The poles are represented by cross. Poles are represented by cross always. ठीक है? The poles 1 by 3 and 1 by 2 है. And the other value, these are called zeros value. So it should not be the zeros value, मतलब z is equals to 0 हो जाएगा direct, and z will be equal to 3 by 2. So 3 by 2 will come somewhere here. 3 by 2 value will come somewhere here, and z0 is here. This is the value of z0, and then 3 by 2 will come somewhere here. The zeros are located. Zeros are represented by a solid dot, whereas poles are represented by the cross in the z plane. ठीक है? So that is how we represent. These are the values of poles. Poles are these values, and zeros are z equals to 0, z equals to 3 by 2. So these are the poles and zeros value. ठीक है? So this is how we can obtain the poles and zeros value from the x of z. Finally, we have to write it in this form. In this form में ही लिखना है, तभी हम लोग उसको poles and zeros की values locate कर पाएंगे. Otherwise, we would not be able to locate the poles and zeros values. ठीक है? So this was the question that we have to perform. If we are having a function which is having two parts in it, individually we will calculate its x of z, मतलब x of z इसका इस part का अलग रहेगा, इस part का अलग रहेगा. Then we will try to find the where this particular term, ये वाला जो term है ये कहाँ पर converge होगा, so that the complete x of z converges. For that this has to be less than 1, and from here this has to be less than 1, and from here we are getting that mod of z should be greater than mod of 1 by 3, and mod of z should be greater than 1 by 2. And finally we have taken the common region out of both the region. ठीक है? तो common region is the ROC will be mod of z greater than 1 by 2, that will be common, and that becomes our region of convergence for this particular question. ठीक है? So that is how we have solved, and finally when we solved our x of z, we got the poles and zeros values also. Yeah. Now the next question. Determine the Z transform and ROC of x of n equals to a to the power n u n minus p of n into u of minus n minus 1. Now from here we can make out that our x of n has again two parts. The first part is a of n un. It's a single-sided sequence. ठीक है, that is it is for positive values of n. The second one is again a single-sided sequence, but it is for all the negative values of n. मतलब u of minus n minus 1 will be existing for minus infinity to minus 1. ये कहाँ से कहाँ तक exist करेगा? From minus infinity to minus 1, and this will exist for n0 to infinity. Hence, we'll be getting all the values here. मतलब यहाँ पर this is existing for positive values of n, and this is existing for all the negative values of n. Now let's see how can we solve this question. Solution. We'll directly write x of z. This is for n 0 to infinity. The first term a to the power n z to the power minus n. Now the second term minus summation n. This one, as we have already discussed, it will be from minus infinity to minus 1. ठीक है? This is b to the power n z to the power minus n. Now how can we solve this particular part? ये part को हम कैसे solve कर सकते हैं? We can just replace the n by minus n as well as including n equals to 0 here. ठीक है? यहाँ पर हम n को minus n replace करेंगे as well as will include what? Will include n equals to 0. That we have done in previous lecture. So let us see. This x of z will be as it is n0 to infinity a to the power n z to the power minus n. This becomes minus, ठीक है, ये minus है, since we are adding 1 here, तो यहाँ पर it will be plus 1, ठीक है, minus, this is summation n will change from 0 to infinity. Now since we are adding 1 inside it, so the 1 will be taken outside as well. N equals to 0 पर the entire term will become 1. Hence we have to take 1 outside it also. So this becomes 1 minus summation. This becomes b to the power minus n z to the power n. ठीक है? So this is going to be our final summation after making changes in the second term. हमें इसी में ही पूरा summation में change करना है. We have to just add n equals to 0 to it. That we have already done in the previous lecture. You can just see the previous lecture video. हमने इसमें n equals to 0 add किया and we have substituted n by minus n to bring it into this form. What is the purpose of doing that? We want our summation in this particular form from n0 to infinity. n0 to infinity, so that becomes easy for us to write the answer of x on z. ठीक है? Now let us write the answer and then see what would be our ROC of it. Now the x of z can be written as the first one, summation n 0 to infinity a z to the power minus 1 का whole n, ठीक है, plus 1 will be as it is minus summation n 0 to infinity b to the power minus 1, this becomes b to the power minus 1 into z का whole n. Now this can be written as 1 by 1 minus a z to the power minus 1, as we know that this is the answer of this particular summation, plus 1. Now this can be again written as minus 1 by 1 minus e to the power minus 1 z. Now this is going to be our final x of z. ठीक है, हमारा x of z है, इसको हम further solve कर सकते हैं, that is up to us. Now this अगर हम इसे solve करते हैं, hence for x of z to converge, what should be the condition? Mod of a z minus 1 should be less than 0 and mod of b minus 1 b to the power minus 1 z should be again less than 1. From this the ROC is what? Mod of z greater than mod of a and mod of z less than mod of b. Now mod of z is greater than mod of a and mod of z is less than mod of b. Now there are two cases. कि अगर a और b पे डिपेंड करेगा कि what are their values, since we have taken just in terms of a and in terms of b, so that matters कि आपका a और b क्या है, whether a is greater than b or b is greater than a. ठीक है. Now if we take the condition case 1, this is our ROC, this is what we have got our ROC. ठीक है. इसका मतलब क्या है, what does it mean, that the mod of z is greater than mod of a, मतलब ROC lies in the exterior of the circle of radius a. ROC lies in the exterior of the circle of radius a, and from this it is saying that ROC lies in the interior of the circle of radius b. इसका मतलब है it is lying in the interior of the circle of radius b. यहाँ पर b के अंदर होगा, यहाँ पर a के बाहर होगा. But what do we want? We want a common region. We want a common region where x of z may converge. ठीक है. अलग अलग होगा तो it is not possible. Now for that, let us take case a when a is greater than b, where a is greater than b. Now since according to our condition, if I am plotting, let us say b is somewhere here and let us take a is somewhere here. ठीक है. b is somewhere here and a is somewhere here. So I will just plot a circle with radius b and with radius a. Now according to this condition, what I am saying is ROC should be greater than a. मतलब the region of convergence greater than a, मतलब exterior of the circle of radius a. ठीक है. This part, and it is saying it should be interior of the circle of radius b, मतलब ये वाला part होना चाहिए. Now since with this condition when a is greater than b, we are not getting any common region. Okay, we are not getting the region which is common here. So this particular condition should not be valid. In this one, x of z will not converge. Then x of z does not converge. ठीक है. So what it is saying, यहाँ पर ये region हो जाएगा ROC का, यहाँ पर ये region हो जाएगा, and since there is no common region if a is greater than b, then x of z does not converge and ROC does not exist. ठीक है. ROC does not exist. Now we have to take the another case. The another case is case 2 when a is less than b. The first condition was when a was greater than b. And the second case is when a is less than b. Now when a is less than b, we can get our ROC. Let us take a somewhere here and b somewhere here. So if I plot a circle with radius a, it will be like this, and if I plot a circle with radius b, it will be like this. And what it is saying, the ROC is mod of z should be greater than a. That means this particular region. ठीक है. मतलब ये b के बाहर भी चला जाएगा. That doesn't matter. But what is the second condition, that mod of z should be less than b. मतलब again coming this particular region, तो ये वाला region भी पूरा cover हो जाएगा. It will cover the entire region of the circle inside b. And for the first condition, it will cover the entire region outside the circle A. But what is common in both is this particular region. This region is common in both. ये पूरा region common हो जाएगा. ठीक है. So this region is going to be our ROC, final ROC. ठीक है. Which is outside the circle of radius A and inside the circle of radius B. Clear? So this is going to be our ROC. तो ROC हम कैसे लिखेंगे? How we will write the ROC? That is, the ROC is mod of A less than mod of B, that is greater than A, then less than mod of B. ठीक है. So this is how we'll write our ROC. Mod of A, that is greater than A and that is less than B. ठीक है, so this is going to be our ROC for the question that was given to us, in which we had one function, one term which is un, another term was u of minus and minus 1. So in that case we'll get an ROC which is a kind of ring. एक ring form में रहेगा where it will be in between certain values, that is it is greater than a and it is less than b. ठीक है, so this is a condition for ROC for the question which was given to us. So this is how we'll solve these questions. Now we have certain conclusions about the ROC. We'll write those conclusions, and these are the important conclusions to understand about ROC. ठीक है, conclusions. First one, the ROC of a causal sequence. Causal sequence क्या होता है? Causal sequence is the sequence which exists only for n greater than 0, which doesn't exist for n less than 0. So the causal sequence is the sequence which exists for n greater than 0 only. Is mod of z greater than mod of a, that is the exterior of a circle of radius a. ठीक है, exterior of a circle of radius a where z equals to a is the largest pole. जहाँ पर z equals to a will be the largest pole in x of z. Now why is this saying that when z equals to a will be the largest pole? मतलब क्या है कि ROC कहाँ रहेगा? Exterior of the circle of radius a. Radius a में जो भी सर्कल रहेगा उसका पूरा outer part will be the ROC. And we have one statement which says that ROC never contains poles. ROC doesn't include poles inside it. ठीक है, तो ROC रीजन में, रीजन ऑफ कन्वर्जेंस में कभी भी पोल्स लाई नहीं करता है. So that is what it is saying, is z equals to a will be the largest value of pole in x of z and the other poles will be the lesser value than a. ठीक है, so that is what it is saying. Second point, the ROC of non-causal sequence. Non-causal sequence is mod of z less than mod of a, that is the interior of a circle of radius a. ठीक है, where z equals to a is the smallest pole in x of z. ठीक है, so what it is saying कि अगर ROC is a non-causal sequence, that is for negative values of n, non-causal sequence are the sequence which exists only for the negative values of n, that is for all negative values of n. Then in that case ROC is mod of z less than mod of a, which is the interior of the circle of radius a. मतलब circle of radius है a का सर्कल है तो उसका अंदर वाला जो पार्ट रहेगा that will be completely our ROC. Inside the circle will be the ROC. Now in that case z equals to a will be the smallest pole. Definitely that I have said कि ROC में कभी भी pole lie नहीं करता है. Pole never exists in the ROC, in the region of convergence. So in that case z equals to a will be the smallest pole and the other poles will be the values which are greater than z equals to a. ठीक है, third point, ROC of a two-sided sequence. As we have seen ROC of a two-sided sequence in the previous lecture a ring in Z plane और the या तो रिंग होगा और the Z transform does not exist at all. ठीक है, या तो रिंग फॉर्म करेगा as we have seen in this case there is a ring which is where the ROC is mod of z greater than a and it is less than b. So that is a kind of ring which is formed if it is a two-sided sequence or else it will not exist at all. And in the previous case as we have seen when a is greater than b, अगर a greater than b होता है तो in that case the ROC will not at all exist. ठीक है, the ROC doesn't exist in that case. So that is our third. And if we are having the another point, the ROC of, let me write it here. The ROC of the sum of two or more sequences. For more sequences, as we have already seen कि अगर दो more sequence एक साथ रहते हैं, दो और दो से ज़्यादा sequence अंदर रहता है, then is equal to the intersection of the ROCs of those sequences. ठीक है, तो अगर आपके दो और दो से ज्यादा sequences का summation है तो in that case ROC will be the intersection of those sequences. मतलब first ROC को हम लेंगे, second ROC को लेंगे और दोनों में जो common region आ रहा है that will be our ROC. The intersection is an important term here. तो जो intersection point रहेगा that will be the ROC of the sequences if the sequences are sum of two or more sequences. Clear now? So these are all the conclusions about the ROC. Now let us go into the another topic. Z transform of now till now we have been obtaining the Z transform of infinite duration sequences. हम कहाँ से कहाँ तक लिखते थे? 0 to infinity, minus infinity to minus 1. That is for infinite duration sequences. So we will be writing now the Z transform and ROC of finite duration sequences. Finite duration sequences. ठीक है, now this is again an important topic. Finite duration sequences मतलब the x of z is given to us. ठीक है, x of z is given to us. Sorry, finite duration sequences मतलब x of n will be given to us for certain durations. ठीक है, now let us see for particular causal sequence. For causal sequence. Now for causal sequence, it is saying ROC is entire Z plane except at Z equals to except at Z equals to 0. ठीक है, तो ये बोल रहा है कि for causal sequences if I am having a finite duration causal sequence then in that case the ROC is the entire Z plane except at Z equals to 0. Now let us see for which values of Z the ROC lies. Now let us take the example x of n. It is saying a finite duration and the causal sequence. X of n is given by finite duration मतलब 1 0 -2 3, 5, 4. Now this is a finite duration sequence as well as causal sequence. Causal sequence matlab this value is the value of x of n at n equals to 0. What does the arrow signify? The arrow says that this is the value at n equals to 0, and rest all are the values for the positive values of n, the further values of n. Now since this is finite duration of n के लिए ही x of n is defined. ठीक है? So here it is a finite duration causal sequence. Causal sequence मतलब x of n exists only for positive values of n. ठीक है? So this one, if we have to find x of z मतलब हम डायरेक्टली समेशन करते जाएंगे. That is, this is the value at x0, this is the value at x1, this is the value at x of 2, this is the value at x of 3, this is for x of 4 and this one is for x of 5. तो सबका ये वैल्यू आपको पता है. हम डायरेक्टली we can write the values and we can write the x of z of. ठीक है? Now since we know the formula of x of z, what is the formula? We'll have to take the summation n minus infinity to infinity x of n z to the power minus n. Now we can keep the values of n and we can directly write the x of z. क्या आएगा? The first one x of 0 is 1 and this is 0. So ये आपका 1 हो जाएगा directly. This value is 0, so we will not write for n equals to 1. This value is minus 2 into z to the power minus 2 plus this is 3 into z to the power minus 3 plus 5 z to the power minus 4 plus 4 z to the power minus 5. Now this is going to be our x of z. Now what can we see here and what can we observe from here? That all these z powers are negative powers. Clear? All the z powers are negative powers. So in this one definitely we'll be having a denominator of z. Denominator रहेगा ही z because these are all negative powers of z. So denominator रहेगा. So if the what is the condition for ROC to exist and for x of z to converge? That if for x of z to converge, this should be less than infinity. That is what I have already explained to you. This value, that is complete x of z, should be less than infinity. That is, it should have a finite value. Then what should be the condition for this to converge? Because all these values of z, that is the powers of z, are negative. Definitely it exists in the denominator. That means z should not be equal to 0. अगर z 0 हुआ तो ये आपका पूरा infinite हो जाएगा. Are you getting my point? So x of z converges for all the values of z except at z equals to 0. So this is what it means. ठीक है? For causal sequences, for any causal sequence, for finite duration causal sequence, what it is saying, the x of z will converge for all the values of z except at z equals to 0, because these are all negative powers of z and definitely it will exist in the denominator. Negative powers का क्या मतलब है? ये denominator में lie करेगा, right? And if it is z equals to 0, this value will be infinite. X of z will be completely an infinite value, and hence x of z will not converge. For x of z to converge, this has to be a finite value, and for this has to be a finite value, z equals to 0 नहीं होना चाहिए. Clear now? So that is what it means. Z equals to 0 should not be the condition. That is, ROC is the entire z plane, completely z plane except at z equals to 0 for any causal sequence. X of z is having all the values. We can write it here. X of z converges for all values of z except at z equals to 0. ठीक है? So that is the only condition for x of z to converge. Now let's see the another finite duration sequence. The another finite duration sequence is for the non-causal sequence. ठीक है, अगर हम non-causal लेते हैं, if it is a left-handed or the non-causal sequence, anti-causal. Anti-causal sequence, that is which exists only for negative values of n. In that case, for anti-causal sequence, ROC is the entire Z plane except at Z equals to infinite. ठीक है, except at Z equals to infinity. Now here the condition is different. ROC is the entire Z plane again, but except at Z equals to infinity. Now let us take the example and we'll solve this one. X of n, this is an anti-causal sequence, the finite duration anti-causal sequence. X of n is 4, 2, 3, -1, -2, 1. Now this is the arrow. Now arrow represents the value at n equals to 0. So for this, if we find the x of z, this is the value at n equals to 0. ठीक है, ये n equals to -1, -2, -3, -4, -5. So x of -5 is 4. X of -4 is 2. X of -3 is 3. X of -2 is -1. X of -1 is -2. And x of 0 is 1. ठीक है, so these are the different values of x of n, and if we write the x of z, summation n minus infinity to infinity x of n z to the power minus n. Now since it is already z to the power minus n, now it will be converted to z to the power positive values of z, because these are all values are negative. ठीक है, तो here x of z will be क्या हो जाएगा, this is x to the power -5, it starts with -5, तो ये हो जाएगा 4 and z to the power 5, 4 z to the power 5, ठीक है, प्लस x to the power -4, यहाँ पर x to the power -4 है, 2 z to the power 4, plus that is 3 z to the power 3. This value is -1 minus z to the power 2. This value is -2 z to the power 1 plus 1. ठीक है, so that is how it's going to be. मतलब आपका जो expression रहेगा x of z का, ये पूरा ये रहेगा. Now since we can see that these are all the values, the positive powers of z, ये सारे आपके क्या है, positive powers of z है. Definitely for x of z to converge, z should not be equals to infinite. Z की कोई infinite value नहीं होनी चाहिए. So from here we can directly write that for x of z to converge, x of z converges for all values of z except at z equals to infinity. ठीक है, so except at z equals to infinity, the ROC is the complete z plane, the entire z plane except at z equals to infinity. So this is for anti-causal sequence. Now we can easily write the condition for non-causal sequence. Non-causal sequence is a kind of sequence which exists in both the directions. मतलब आपके positive values पे भी exist करेगा and negative values पे भी exist करेगा. So the third one is a two-sided or non-causal. ठीक है, for this क्या होगा, ROC is the z plane except at z equals to 0 and z equals to infinity. दोनों कंडीशन होनी चाहिए. There should not be any infinite value and there should not be 0 as well. दोनों कंडीशन satisfy होनी चाहिए. Then we can say that it is a two-sided sequence. मतलब ROC will exist only for this value z equals to 0 and z equals to infinity पे भी exist नहीं करेगा. बाकी it will have all the ROC, the entire z plane. Now if we take the example here, x of n 2 1 minus 3 4 2 1 5. Now since this one is an arrow, मतलब ये क्या है आपका x of 0. This is x of minus 1. This is x of minus 2. This is x of minus 3. This is x of 1. This is x of 2. This is x of 3. So it is existing for both the values of n, for negative as well as positive values of n. If we have to find the x of z, we can directly write the x of z as x of minus 3 से start हो रहा है. That is 2 z to the power 3. It will be 2 z to the power 3. Since it is z का minus n होता है, it will become 3 plus z square. Since it is 1 minus 3 z plus 4 z to the power 0, ठीक है, plus 2 z to the power minus 1 plus z to the power minus 2 plus 5 z to the power minus 3. Now since it has both the positive powers of z as well as negative powers of z, दोनों हैं, so that is the only reason it is saying that it exists for all the values of z, that is the entire z plane, except that for this z equals to infinity and from here z equals to 0. So except that z equals to 0 and z equals to infinity is the condition. For these two cases only, except at z equals to infinity and z equals to 0, the entire z plane will be the ROC for two-sided sequence. ROC is, as we have written, the entire z plane except at z equals to 0 and z equals to infinity. So this was all about the ROC for finite duration sequences. If it is a causal sequence, मतलब for positive values of n, the ROC will exist. That is, ROC will be the entire z plane except at z equals to 0. ठीक है? If it is a anti-causal sequence, that is, it exists for only for negative values of n, the ROC will be the entire z plane except at z equals to infinity. That is what we have written here. Now if it is a non-causal sequence, non-causal sequence क्या होता है? When x of n exists for both the sides, that is for positive values of n as well as for negative values of n. In that case, the ROC is the entire z plane except that z equals to 0 and z equals to infinity. मतलब ये दोनों conditions satisfy करें. ठीक है? It should satisfy both the condition कि z equals to 0, z equals to infinity को छोड़